Now, the quick way to do this is by peeking at the number plane, at spotting the slope by counting how we're going to go vertically and horizontally. Now, that way is very fast, and I'm going to teach you how to do that in 3 simple visual steps. So that's what we're going to do now. Then we're going to go to the formula. So let's begin with the 3 simple steps here. And the first step is to identify, just by looking at it, what the gradient is in terms of positive or negative. Now remember, I gave you a physical way to know that. And the physical way, if you recall, is that if you have a gradient like this, in other words, to your left, that's going to be a what? It's going to be a negative gradient. So if it's to your left, negative gradient. Now, if you go like this to your right, that's going to be a positive gradient. So that's positive. That's a big plus. Now have a look at what I'm doing and have a look at that. Looks like they're both positive, yeah? So this is a positive gradient, so we know it's going to be a plus. So let's write that down, that m, whatever the rise over the run is going to be positive. So there's the plus there. Now, step number 2 is identify the rise. So as we look at the rise of this line, we go up 1, 2. So we're going up 2. Let me just mark them out. So it's 1, 2. So the rise is 2. Let's put that in. So that equals 2 over. And now the run, what's that going to be? Well, it's from this point here across that way. So it's just 1 unit. So that's going to be 1. So the final answer is 2 over 1. We can simplify it. It's like a fraction. So the final answer, gradient, and by visually inspecting it, is 2. I'll put that little plus there because it's a positive gradient, as you recall, that way. Now let's confirm and validate that particular gradient over here with the gradient and slope formula over here by putting down and plotting the coordinates from here up over here, so we can slot and substitute them in there. So it's going to be 2 steps. Step number 1 is to identify the coordinates where this line goes through, and then write them up, mark up and label each ones, and then slot them and substitute them into the gradient formula. So let's do that now. Let's go straight for the coordinates. So the first coordinate would be right over here. On this particular occasion, it's going to be 0, 2. So let me write that up. So coordinate number 1 is 0, 2. Now coordinate number 2, where that line goes through, because that's the gradient we're interested in, it goes through this point right over here, and the coordinates for that, or the ordered pairs, is -1, 0, because it's on the actual x-axis. So I'll repeat that, -1, 0. Okay, next all we got to do is plot and label which is which. So I'm going to label these up as the first point will be 1 and the second one 2. So this will be 1, x1, y1, and x2, y2. We're going to slot these particular points into this gradient slope formula. So let's do that now. We've identified and labeled the coordinates. Let's see, the gradient formula asks us for y2 first of all. Let's find y2 over here on the coordinates, and we go all the way across here, and we see that it's a 0. 0 minus, we have y1, let's go across the y1, and y1 is right over here, so that's a 2. 0 minus 2, all over, let's go down here in the bottom left, we have an x2. Let's find x2, all the way across here, there's our x2, it's actually -1. And then we have the minus, bring that down. And finally x1, let's go across to x1, and x1 is right here, conveniently, it's just a 0. Let's put that in. Okay, let's go 0 minus 2, that's going to yield -2. That's a negative. And on the bottom, it's -1 minus nothing, so it stays -1, doesn't it? -1. Now, you might recall from directed numbers, when you have a negative divided by a negative, it turns into a positive. That's right. So it's going to be a positive answer. So that's going to equal the gradient analytically for that line. Let's see if it confirms that we get m equals +2. Negative over negative is positive, so it's going to be a plus. 2 over 1 is 2, and that confirms and validates the visual format. So they're both gradients are m equals positive 2.